Algebra 2 class, this is Miss Graham, and today we are going to be looking at solving systems of linear equations through elimination. Let's go ahead and read some background on why we are solving by elimination here. Sometimes it is difficult to solve a system by graphing or substitution, meaning maybe it's not in graphable form, or maybe it's really hard to get a variable isolated by itself. The last method to solve is by using elimination. Now, in elimination, you're going to solve to eliminate, aka get rid of one of the variables. In some cases, you must multiply each equation by a number so that the terms in one variable combine to 0 when the equations are added. Then, we kind of use a little bit of substitution, throwing it back, with the value of that variable to find the value of the other variable. So there's a lot that they're explaining here, but the best way I can say it is that we are trying to get rid of, basically terminate, one of the variables to solve for the other one. It's okay. It's neighbors. It's neighbors. It's neighbors. Let's go ahead and look at problem number 1. So I highlighted each of the equations just so we can go back and see, hey, the first equation is in red, the second one is in yellow. So it's going to be a little bit weird, but these two equations we're actually going to combine together. Sometimes the elimination method is called linear combinations because we combine or add together the two equations to see something that happens. Now, the reason that I'm adding these two equations together is we're going to add like variables downward. We can see that we have the variables x's above each other, the y's, and our constants. We also want to make sure that both variables are underlying underneath each other, as well as the numbers. The equal signs line up as well. So looking at this and looking to see what happens, when we add x plus x, we get 2x. Now this is the cool part. When we add negative 1y plus y, they actually cancel out. So this problem is really cool in regards to seeing how the variable cancels out right away. Lo and behold, we can then add negative 1 plus a negative 3. That gives us a negative 4. And looking at this, we can see we have the variable isolated by itself, just the x. So now we can go through the process of figuring out how to get x by itself. So we divide by 2 on both sides, and then that way we get x equals a negative 2. I know, it's kind of nice to be able to add those linear equations together. Now, we know when we have our solution, right, we have to write it as a point, x comma y, and right now we don't know what that y value is. Okay, so how do I go about this, finding that y value? Well, I'm going to go ahead and pick that negative 2, and I can plug it back into either of the original equations. Just like we did for solving by substitution, we could do that as well. Sometimes with the substitution, it was nice to plug it back into kind of the reformatted or reworked equation, but in this case, it doesn't have one of those. So you can choose either the yellow or the red equation. I'm just going to choose the yellow equation just because I see that y is a positive here, and it might be nice to get it by itself that way. So let's go ahead and we're going to plug in that negative 2 in for x right here. So we get negative, let's try this again. We get negative 2 plus y equals a negative 3. And then how we get y by itself is we add 2 to both sides, so that way y equals a negative 1. Awesome. So looking at that, we can see we were able to solve and find the solution. Perfect. Now, what I did was for my check, I kind of moved my solution box a little out of the way so I can go ahead and check my answer to see if it's correct or not. So let's go through the check process where we're going to take both our red equation and we're going to take our yellow equation. We're going to write them down. And then we're going to plug back in our solution of -2, -1 into x and y. Remember, -2 is x, -1 is y. And we want to make sure both equations balance, meaning both of them show us the same number equaling the same number. So let's go ahead and plug -2 in for x, subtracting a -1 for y, and see if we get -1. Well, when we minus a negative, it's like adding a positive. So -2 plus 1 is -1. Hey, so we know it checks out for the first equation. Let's try the second one. -2 plus a -1. Hey, we can lo and behold see that is -3. So -3 equals -3. Perfect. That checks out. Again, the check process is optional. You do not have to do it. From here on out, we're not going to do it, but if you want to do it on your own, you can. Let's go ahead and look at number 2. So in this case, we can actually combine the equations downward because we can look at and see, hey, x's are going to cancel out. When I add the y's, don't forget that's a 1y in front of just the y. So I get 3y equals -9. To get y by itself, I divide by 3. So look at this. I get y equals -3. So for my solution, I actually know what the y value is. It's -3, but I don't know what the x value is yet. Again, we can plug it back into either one of those equations. I'm going to choose actually the first one this time just because it's a positive in front of the 2x. It's going to make my life a little bit easier to solve for. So let's plug in our y value of -3. And I put just minus because we know adding a negative is the same thing as subtracting. So I get 2x minus 3 equals -10. Let's add 3 to both sides. So that way I get 2x equals a -7. And then I divide by 2, so I get x equals, and it's okay if you have a decimal. That's fine. In this case we do, so I get a -3.5 for my x value. So my solution is -3.5, -3. Let's go ahead and move on to problem number 3 now. Again, when we're approaching these problems, we got lucky on the first 2 problems where we could just easily add the 2 equations together and a variable cancel that. But this one's a little harder because if we add x plus x, oh, well, that's 2x. If we add a -y plus 3y, oh, that's 2y. Neither of the variables cancels out. So we have to do one more step before we actually add the 2 equations together. What I'm actually going to do is try to figure out how I could cancel out my x's. Now, why did I choose my x's? Well, you could choose your y's. Doesn't really matter which one. But I try to make sure that the numbers in front of the x values are the same. In our previous problems we looked at and we saw maybe we had a +1 and a -1. Or we actually had, the same number in front of the variables, but it just showed that they were opposite signs. So that's kind of our goal here. That's what we did in number 1, and that's what we did in number 2. So that's why I'm going to target focusing on the x values there. In order to do this, I'm going to rewrite my second equation. It'd be really nice if that was a -x instead of just a +1x. So what I'm going to do is I can't just change the x in front. I can multiply that whole bottom equation by a -1 and then make sure I distribute that -1 to each of the terms. So that way I still have my first original equation staying the same, but now my second equation is now a -1x, a -3y, and a -6. And now when I combine the equations and add downward, lo and behold, I can see that the 1x cancels with a -1x. When I add downward, I get a -4y equals a positive, well, actually, not a positive, a negative 4. 2 plus a negative 6 is a negative 4. So this one had one extra step before we could combine the equations. And now we can divide by negative 4 to get y by itself. So y equals negative 1. Sweet. Not too bad. So we know so far for our solution for that 1 point, we got the y value as negative 1. Again, we have to plug in this negative 1 for y into one of the original equations, or we could even plug it in to the new rewritten equation. It's not going to matter. Doesn't hurt either way, but I'm just going to plug it in back to the first equation. So let's plug it on back in. So I'm going to have x minus a negative 1 because I plugged in the negative 1 for my y value. So don't forget, minus a negative is really adding, right? Be careful with that. So really, when I rewrite this, I have x plus 1 equals 2. So now when I subtract 1, x is going to be 1. So that's going to be my solution I'm working with. Let's go on to question number 4. Let's try to eliminate our y values now. So looking at this problem, we can see, oh, it's great that they both have the same coefficient in front, but they're different signs. So I have to figure out how to make one positive and one negative. It doesn't matter which one you want to multiply the equation by, a negative to change into a positive, but I decided to use the first equation. So when I distribute that negative 1 to each of those pieces, I now have a negative 1x plus 4y equals a negative 16. So the bottom equation stays the same. 1x minus 4y equals a negative 4. When I start to combine the equations together and add downward, again, I know my y's will cancel. Wait a minute. My x's cancel too. So I'm left with 0 on the left side. When I combine my negative 16 and my negative 4, that's a negative 20. Wait a minute. So the variables disappeared, right? We've talked about this before. What types of solutions this could be if both variables disappear. And we're left with this really untrue statement we're not happy with. So it's not one solution, but think of what other types of solutions it could be. When the equation is not equal, that means it's going to be no solution, I know, right? So if we graphed both these lines on a coordinate plane, it would probably be parallel lines. They would never touch or interact with each other. I wonder if we're going to have some more problems like that. Let's flip to the second page and look at number 5. All right, so for number 5, we can see we can't add the equations together and a variable cancels out. So we are going to have to multiply one of these equations by some number to try to get the x's or y's to cancel. So you can choose. Do you want x's to cancel out or y's? I'm already looking at this and I'm kind of wanting to pick the x's. So let's stick with that. So think of if I have a positive 2x, what is going to cancel with it down here? That's right, a negative 2x. So we have to multiply this whole entire equation by negative 2. But then don't forget, we have to distribute that negative 2 to each of those pieces. So my first equation stays the same. Second equation, I now got a negative 2x plus 4y equals a negative 16. Now we know when we combine the equations together, oh, the x's will cancel. The y's cancel in this case. Oh, well, maybe it's going to be no solution. But wait a minute. Look at what happens to our constants. 16 plus a negative 16 cancels as well. So we get 0 equals 0. So again, both variables disappear. Right? But wait a minute. 0 does equal 0. We're happy in this case. So it's not going to be no solution. It's not going to be one solution. It's going to be infinitely many solutions. So just like what we learned about before. Infinite solutions. All right, we've done a couple problems together, but now I want you to do this next problem, number 6, on your own. And here's what I'm going to have a goal for you. I want you to go ahead and cancel out the y variables. So go ahead, try this problem with elimination and see if you can cancel out the y variables. Pause the video right now while you're working and then press play to check your answer. All right, let's go ahead and check our work. So in order to cancel out the y's, we have to make sure that this top y is a negative 3y, because this one's a positive 3y, this one's a negative 3y. Again, I usually try to add the equations together, so that's why I multiplied by a negative, so that way the y's canceled. I then solved for x and got negative 3. Now, this is your choice. You can plug it back into the first equation, the second equation, even the new multiplied equation. I just chose the second equation to make it a little easier since the numbers were smaller, generally speaking. So when I plugged that back in, solved for y, I got 4. So my solution is negative 3, 4. Now, we're going to start to look at some problems where we even take it a step further. Maybe multiplying one equation by one number isn't going to do. So looking at numbers 7 and 8, let's start with 7. If you look at your x's, 3 and 5, yeah, there's not really a nice number, a nice whole number I can multiply one of those by to cancel out the x's. Same with the y's. You can also look at number 8, 2 and negative 5, as well as 8 and 20. Those are kind of ugly numbers. This is the step where we're going to have to actually multiply both equations. Gosh, I know. Okay, all right, let's look at this. Let's start looking at figuring out how we could cancel out the y's in number 7. So you know me, I like to highlight my two equations, and I want to figure out how I can cancel those out. Well, let's see. Is there some common number that maybe 2 and 5 are, divisible into? Maybe some common goal number that I can multiply my first equation by something and my second equation by something, so that way I rewrite both and I add the y's together and they cancel. Here's my hint. Think of if I multiply 2 and 5 together. Maybe if I had that common number as 10y. Maybe one of them is a positive 10y and one's a negative 10y. It's really not going to matter which one is which. But let's say we want the negative 10y on top and we want the positive 10y on the bottom. We know when we add those equations together, they will cancel out. So we have to figure out, how do I get a negative 10y on top? What do I multiply already a negative 2y by to get negative 10y? That's right, it's 5. So guess what? I'm going to multiply all of the 3 terms on top by just a positive 5. So that way, what do I get? I get a 15x, a negative 10y, and that equals 10. I'm going to go through the same process with my bottom equation. I want to get a positive 10y down here. So what do I multiply negative 5y by to get positive 10? That's right, a negative 2. So I have to multiply each of these by negative 2 to see what I get. So a negative 2 times a negative 5x, that's a negative 10x. I already talked about how I have a positive 10y. So then I have to multiply negative 2 times 10. So that's negative 20. So that's kind of the thinking process that we're going through. And remember, our goal is to cancel the y's. So now when I add the equations downward, I get a 5x equals a negative 10. And look at that, I can divide by 5 on both sides. So x equals negative 2. Again, for my solution, I want to make sure I have some type of x and some type of y. Not sure what it is just yet, but we're going to figure that out. Again, we can plug in that x is negative 2 into either the first or the second equation, and even the rewritten ones. But you know me, I like to have some smaller numbers, so I'm just going to choose the first original equation of 3x minus 2y equals 2, and plug back in that negative 2 in for x. So really I have 3 times a negative 2 minus 2y equals 2. So I have negative 6 minus 2y equals 2. I add 6 to both sides. So I have negative 2y equals what? 2 plus 6 is 8. Divide by negative 2. Ooh, and I'm going to have to move my work over here. So y equals a negative 4. So that way, that's my solution I'm working with. Go ahead and pause the video right now. I want you to try number 8. Now, before, our goal was to cancel the y's. So I'm going to make a goal now for I want you to cancel the x's. So try canceling the x's on this problem right here. Now, if you're at the point in the video notes where you're ready to start your homework, you've had enough practice, go ahead and you can stop the video here and go ahead and get started on your homework. If you're someone who's like, I need a little bit more practice, I want to try some problems on my own and then check with Miss Graham's answers before I go back to my homework, totally fine. That's what we're going to do right here. So, again, if you want some extra practice, you're going to get to check your work with mine here. I'm just highlighting my equations so that way you can see what we're working with. Again, for numbers 9 and 10, if you want to stay on the video and watch them for extra practice, you can. Otherwise, if you're good to go, you can stop the video right now and get started on your homework. So for number 9, we can choose to eliminate x or y, as well as for number 10. Just to switch it up for us, I want you to practice eliminating y for number 9 and eliminate x for number 10. So I'm going to write that as a goal. So our goal for this is to eliminate, I'm just going to use a little bit of a thinner pen for this. So our goal, let's get rid of or eliminate y for 9. And our goal will be to eliminate x for number 10. So go ahead, pause the video, try those two problems, work them out, and then come back and check with me when you think you got your answer. All right, so I was able to start number 9 and complete it. So I decided to cancel the values. One's already negative and one's a positive, so that makes it easy to see what to multiply by. First equation I multiplied by 7. Second one I multiplied by 2. Saw the y's cancel, solved for x and got negative 1. Then plug that back into one of the original equations. Or you could do the manipulated ones, but you know me, I like to work with smaller numbers, so I chose the first equation, solved for y, got y as negative 5. So my solution should be negative 1, negative 5. Now, before I show you the work for 10, I just wanted to point out that there's actually a couple ways that you could do this problem. We decided to eliminate the x's, and what I wanted to go over was the x's have the same positive and negative values, right? They both have the same sign. We want one a positive, one a negative. So I have to multiply one of those equations by a negative to make it a positive. It could be the first equation or the second one. I decided to choose the first one. Again, if you chose the second one, you should still get the same solution that I did, but I just wanted to preface that before I show you my answer. All right, checking our work for number 10, we should have gotten a solution of 10-2. Keep in mind that sometimes you're going to work with bigger numbers, so you can always pull out a calculator to use just in case. All right, go ahead and start your elimination homework. Have a good rest of the day.